Hi, I'm Jesse, one of the explainers at InfoVault. Have you ever wondered how to host a website from your own machine? Whether it's for a personal project, a learning experience, starting your web hosting journey, or just setting up a development environment, this quick guide has everything you need to get started. In addition to web hosting, this guide helps you understand the fundamentals needed to host a game server or set up custom services like home or office automation by configuring the appropriate ports and using the right tools for your specific needs. Hosting a website from your machine involves setting up your device, configuring your network, and preparing your internet environment. Setting up your device. Spare machine. You need a spare machine with no data on it. If you've got data on it, back it up to another storage medium. Operating system. Install your preferred operating system, ideally one optimized for hosting. Components. You need the following components installed on your operating system. A web server. Ensure that the installed web server is listening on port 80 for HTTP traffic and port 443 for HTTPS traffic. Configure your web server to handle both HTTP and HTTPS requests, typically by specifying your domain name and the website's folder path for each protocol. This setup enables the web server to directly deliver static websites over both HTTP and HTTPS protocols. For dynamic websites. If your website is dynamic and built using some programming or scripting language and uses a database to store its data, then, based on the technologies used, you will also need the following components installed, configured, and running on your machine. Request processing component. For static websites, this component maps URLs to file paths. For dynamic websites, it routes requests to the application's specific code for execution by the execution environment. Execution environment executes the required application's code. It interacts with database server if needed and produces the final output and sends it back to the request processing component, and the request processing component sends it back to the web server. The web server then serves the output to the visitor that requested the web page. Database server executes database queries embedded in the application's code when the execution environment sends them to the database server. Here is a tip. Use your web server's configurable virtual blocks, called virtual hosts in Apache and server blocks in Nginx, to host multiple websites on the same machine. Based on web server and technologies used in building your website, setup varies. Refer to the official documentation of your web server and associated technologies for specific setup instructions. Website. Design, develop, and deploy your website on your web server. If the website is dynamic, update its configuration file to integrate the database. Configuring your network. You need a router. Every device on a network is identified by a unique IP address. There are two types of IP protocols. 1. IPv4. 2. IPv6. Structure of IPv4 address. An IPv4 address consists of a network prefix and a unique host identifier. Network prefix is used to identify the network, such as a local network or the internet. Unique host identifier is used to identify the device within that network. Structure of IPv6 address. An IPv6 address primarily consists of a network prefix, subnet ID, and unique interface identifier. Network prefix identifies the network. Subnet ID identifies the subnet within the network. Unique interface identifier identifies the device within the subnet. Depending on the type of IPv6 address, such as a global unicast address, unique local address, or multicast, the construction format may vary. Different portions of the address are used for purposes like routing, subnetting, and identifying devices. To support both protocols, log in to your router's admin interface and enable dual stack mode on your router. This ensures each device on your network receives both an IPv4 and IPv6 address, enabling compatibility with both IPv4 and IPv6 traffic and seamless communication, regardless of the protocol used by incoming internet traffic. Dynamic address assignment. IPv4. The router uses DHCP to assign a private IPv4 address to each device on its network. IPv6. The router uses either DHCP-v6 or SLAAC, stateless address auto-configuration, to assign a unique local address, ULA, to each device on its network. ULAs are unique local IPv6 addresses. Both ULAs and private IPv4 addresses are not directly accessible from the public internet, but can be reached using techniques like network address translation, NAT, such as port forwarding, which allows traffic to be forwarded from a public IP address to an internal device. Please note that the discussed router's network behavior is based on typical or basic configuration circumstances. By understanding your network behavior under various configurations and specific needs, you can achieve more tailored setups as required. Preparing your internet environment. Internet connection with a static public IPv4 address and static IPv6 prefix. You need an internet connection with a static public IPv4 address assigned to your router and a static IPv6 prefix provided by your ISP through DHCPV6 prefix delegation, DHCPV6 PD. This enables the router to assign a global unicast address, GUA, to each device using either DHCPV6 or SLAAC. GUAs are global unicast IPv6 addresses. Both public IPv4 addresses and GUAs can be directly accessed from the internet. Static address assignment. Dynamic IP addresses often change. To ensure consistent accessibility, assign your machine a static private IPv4 address. Assign your machine a static ULA IPv6 address based on your router's address assignment methods. With this setup, your website is accessible over your local network using your machine's private IPv4 address and ULA IPv6 address. Assign your machine a static GUA IPv6 address based on your router's address assignment methods. Port forwarding. Log in to your router's admin interface and set up port forwarding. IPv4. Forward port 80, HTTP, requests to your machine's static private IPv4 address and its internal port 80. Forward port 443, HTTPS, requests to your machine's static private IPv4 address and its internal port 443. IPv6. For IPv6, port forwarding is unnecessary since GUA IPv6 addresses are directly accessible from the internet. Firewall. Ensure firewall rules on both your router and operating system allow inbound and outbound traffic on ports 80 and 443 for both IPv4 and IPv6 protocols. Ensure other ports remain restricted to prevent unauthorized access. With this setup, your website is accessible over the internet using your public IPv4 address and your machine's GUA IPv6 address. Please note that the discussed ISP provisioning of a static public IPv4 address and a static IPv6 prefix is based on traditional or commonly used methods of provisioning. By understanding your ISP's IP address provisioning methods, you can always set up your hosting environment appropriately. Domain and DNS. First, visit your favorite domain registrar's website. Don't worry about the components like the authoritative name server, DNS resolver, etc. that are just added to your screen. Each will be explained later. Now, register your desired domain name with your domain registrar. Next, go to the DNS management interface provided by your domain registrar. Add an AV record and point it to your public IPv4 address, then save the changes. Saving these changes updates the registrar's server that stores user settings and pushes the update to the authoritative name server. Then, add an quad A record and point it to your machine's GUA IPv6 address. Again, saving the changes updates the registrar's server and pushes the update to the authoritative name server. The authoritative name server stores the records of all domains under a specific TLD or extension. For example, the .com extension has its own authoritative name server that stores the records of all the .com domain names. With this setup, your website hosted on your machine can now be accessed directly from the internet using your domain name over both HTTP and HTTPS protocols. Now, with this, we've successfully set up the device, network, and internet environment. Next, let's see how things work by introducing a visitor's machine. When a visitor tries to visit your domain, example.com, their browser doesn't yet know the IP address of the server hosting the website. Here's how the IP address is obtained. The browser first checks its cache to see if it has recently resolved this domain. If it finds the entry, it uses the cached IP address. If the browser doesn't find the entry in its cache, the request is sent to the operating system's stub resolver. A stub resolver is a component of the operating system that handles DNS queries on behalf of applications. It acts as the operating system's DNS client and is responsible for forwarding DNS queries to an external DNS resolver, like a public DNS server or an ISP's resolver, and returning the results to the application. The stub resolver first checks its cache. If the entry is found, it returns the IP address to the browser. If the stub resolver's cache doesn't have the entry, the stub resolver forwards the request to the DNS resolver, typically provided by the visitor's Internet Service Provider, ISP. The job of the DNS resolver is to obtain DNS records and provide the DNS information found in DNS records like IP address. The DNS resolver first checks its cache to see if it has recently resolved example.com. If no entry is found, the DNS resolver performs a recursive query, starting by querying the root name server. The root name server scans the entire domain name to identify its extension. Based on the domain name's extension, the root name server provides the DNS resolver with the IP address of the appropriate TLD name server. The DNS resolver then queries the TLD name server suggested by the root name server. The TLD name server stores information about authoritative name servers for domain names under a specific TLD or extension. It checks its records for the authoritative name server details of example.com. Once found, provides the DNS resolver with the IP address of the responsible authoritative name server for example.com. The DNS resolver queries the responsible authoritative name server suggested by the TLD name server. The authoritative name server stores the DNS records of domain names under a specific extension, like .com. So, the authoritative name server checks its records for the example.com's DNS records. Once found, it provides the available A and Quad A records of the example.com to the DNS resolver. The DNS resolver caches the DNS records obtained from the authoritative name server and sends the IPv4 address found in A and IPv6 address found in Quad A to the visitor's operating system stub resolver. The stub resolver caches the obtained DNS information and passes it to the browser. The browser caches this information and decides which IP version to use, depending on its support for IPv4 or IPv6 and its network environment. Many modern systems prioritize IPv6 over IPv4, falling back to IPv4 if necessary. If the domain has multiple servers with both IPv4 and IPv6 addresses, the browser will typically try to connect using the first IP address in the list, usually preferring IPv6 if both types are available. If the first IP address is unreachable, the browser will attempt the next available IP address, considering factors like network performance or latency. With the IP address obtained, the browser sends an HTTP or HTTPS request to the server hosting example.com. Upon receiving the request, the web server and other components running on your machine process the request, generate the output, and respond by sending the web page's associated files, such as HTML, CSS, JavaScript, images, and other resources, to the visitor's web browser. The browser's rendering engine processes the received files and displays the web page to the visitor. Security tips. Implement HTTP to HTTPS redirection. Obtain and configure a TLS or SSL certificate on your web server to secure your website. Harden your network and operating system with firewalls and malware scanners. Set custom rules and conditions on your web server for enhanced security. That's it, voila. This is a most comprehensive outliner. A quick outliner guide and comprehensive guide with step-by-step walkthrough of each component explained in detail is coming soon on our channel. Stay connected and tuned. Please check our description box that has thorough manual to help you seamlessly set up your hosting environment. Thanks a lot for watching. This is Jesse, one of the explainers at InfoVault. This video's content was created by Naresh Ramini, a content creator and infographic explainer video designer at InfoVault, who is also the reason for its inception and execution. If you found this video helpful, please give it a thumbs up and share it. To stay updated with our future content, subscribe to the channel and hit the bell icon so you never miss an update. Signing off.
Goodbye.